Well, here we are, day 3 of writing linear equations. We're in our third form. Today's form is the least familiar to you probably. You probably haven't seen many equations written this way, but it is the easiest way to graph. So, and it's kind of the easiest way to write the equations as well. So you'll like it. It's called the point slope form. So it's our third form. So before we start, let's review a little bit about how we've graphed the first two forms. Actually, way back before we even started graphing from forms, could you remember how we graph from tables? This is how you first start graphing before you even know there are forms of linear equations. You don't even know what a linear equation is. You simply are going to graph this. So I always like to stick in a negative, a positive, and a 0, and 3 points. If they're in line, you know you have your answer right. Of course, these are my x's, these are my y's. So if I stick a -1 in for x, that will give me y will equal 5 minus 2 times -1. So y will be, that negative times negative is a positive, so 5 plus 2 is 7. So that would give me a 7 right here. If I stick a 0 in, y will be 5 minus 2 times 0. Well, anything times 0 is 0, so y will be 5. And if I stick a 1 in, I'll get y equals 5 minus 2 times 1. And 2 times 1 is 2. 5 minus 2 will be 3. So let's see that those 3 points do indeed line up. So I have a -1, 1, 2, 3, 4, 5, 6, 7. I have a 0, 1, 2, 3, 4, 5. And I have a 1, 1, 2, 3. And sure enough, they do make a straight line. I'm not very good at making these on the computer, but let me try. So it will go like that, right? So that would be our line that contains those 3 points. So that's how you graph by plotting points. But then we got into Algebra 1 and we started giving them names, the equations. The first one, slope-intercept form. Slope-intercept's the one you like the most familiar with. You see the slope and the intercept looking at you. If we have the equation y equals 2x, well, something's missing there, right? I've got a y equals mx, but there's no b. So it's okay. I can put a plus 0 there because there is no b. And 0, you know, that works. It's a placeholder. So in this case, my slope is 2. My b is 0. If you remember how to graph those, you go to your base camp first. So I go to 0. And then from that base camp, I'm going to rise over run. 2, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. And again, they're in a straight line. So I know I'm good to go. And that line will be not exact, but you get the idea. Whoops, I really messed up that last one. But that's okay. It's this line right here, right? Boop, 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 boop. Forget that one. All right. How did we graph from x and y intercepts? Well, we remembered that with the x-intercept, the y is always 0. And at a y-intercept, the x is always 0. So let's go back to this top one. If we stick a 0 in for y, these are my y's, these are my x's. If I stick a 0 in for y right here, 2 times 0 is 0. So 0. So this whole thing goes away. I'm left with 7x equal 14. Divide both by 7, and x is 2. Okay, then to find my y-intercept, I stick a 0 in for x right here. 7 times 0 is going to be 0. So that whole thing goes away. I'm left with 2y equals 14. Divide by 2, and y is 7. So 2, 0, and 0, 2, 4, 6, 7. I've got my points there. Draw my line, and I am good to go. So that's how we did that. This is all review. Now let's review how we wrote in slope-intercept form. So in slope-intercept form, actually, let's do slope-intercept and then convert it to standard. So we get all 3 of our forms. All right, so here we go. to put it in slope-intercept form if it goes through 1, 3 with a slope of -2. So I have my slope. That's nice. So I have my b. So I need my y equals mx plus b, right? That's what I'm looking for here. Y equals mx plus b. So I'm going to choose the point, and this is my x and my y. So in place of y, I'm going to put a 3 equals my slope, which is -2, times my x, which I grab up here from my point, plus b. And I'm looking for what my b is. That's the whole point of this part. Bring the add 2 to both sides. And looks like b is 5. So my equation then is y equals slope -2x plus b, which is 5. Then to convert that to standard form, remember standard form, you have to have your x's first, then your y's equals a number. So if I look at this, the only difference is to make it standard is I just need to bring this 2x to the other side of the equal sign. So by adding 2x to both sides, now I have 2x plus the y that's already on that side, and I'm left with the 5 over here. There we have it. That is standard form. So I'll review. Now we're moving on to our new stuff. We're going to go into our new stuff. Okay, so let's think about that slope-intercept form one more time. What information do we need in order to write an equation in the slope-intercept form? Well, obviously we needed our slope, and we needed our y-intercept, our b, right? That's why it's called the slope-intercept form. So what do you think we'll need in order to write an equation in something called a point-slope form? Hint, hint. I need a point, and I need a slope. That's the only two things I need. I can get them however I want, and I can write an equation in point-slope form. So in your, go and get out your foldable. So now we're in the last of the 3 windows, the far right-hand side. This is your point-slope form right here. So it's called the point-slope form. And notice it's y minus y sub 1. The 1 is down. It's a subscript. That's why I say sub 1. Equals m, which is the same m is still the slope. Parentheses x minus x sub 1. So what does this mean? Well, somewhere in there, since it's called the point-slope form, there's a point and there's a slope. Well, I know the slope is m. It's always m. And my point is the point made up of this x and this y. X sub 1, y sub 1, whatever that is. Now notice in the formula, these are both negative in front of those. So it's going to be the opposite of what I think it should be. So again, on the front of your foldable, I would suggest you write this as well. That in this formula, the slope is m, whatever your m is. The point is whatever your x sub 1 comma y sub 1, the opposite of those. So let's do some. Actually, open the fold of your third column there. And it says writing in point slope form when given a slope and a point. So here's what you want to write in there. You put the blank in for the blank. You put the slope in for the m. And then you put a negative, whatever your x is, a negative, whatever your y is, for the x, y. Very simple to do. Watch when you see it done, you'll be amazed. All right, so let's write the equation of a line in point slope form that has this slope and contains this point. So I'm going to do y minus the y of my point, which is 4, equals my slope, which is 2, parentheses, x minus the x of my point. And that is all I do. That is a point slope form of a line. Really cool. Very easy. A lot easier than the other ones. Not a lot of manipulation. All right, this next one, write an equation in point slope form of the line with the slope of -5/2 containing the point -2, 3. Well, I've got a point and a slope, so I'm ready to go. So it's y minus the y of my point equals slope m parentheses x minus, what is my x? Oh, my x is a -2. So that's a double negative. So it's going to be a +2 because it's the opposite. So in this case, since this x was a -2, I'm going to put a +2 over here. And since this was a +3, I put in a -3 into the formula, into the form. And there we have it. It's that simple. You can leave that fraction there. You don't have to get rid of fractions. That's as simple as it is. Now, what's different with this problem? Write the equation in point slope form of the line through -1, 3, and 4, -7. What's the difference? The only difference is they didn't give us the slope first. I've got points to work with, I just don't have a slope. Well, we know how to find slope. Oh my goodness, we've been doing it the whole time. So let's go our -7 minus 3, -7 minus 3 over 4 minus -1. 4 minus -1. Oop, double negative. So I have -10 over 5, which reduces to -2. So now I have my slope, and I have 2 points. Well, that's overkill. I don't need 2 points. I only need 1 point. You can use either point you want, but for sake of clarity within when I'm grading, it would be nice if we all used the same point. So we are going to make it just kind of a general rule that we're going to use the first point listed each time. That way, we all will get the exact same answer. All right. So I'm going to use that point, and it's going to be y minus the y, which the y in my point is 3, equals my slope, which is -2, parentheses, x minus, minus 1. So it's going to be x plus 1. And I'm done. So the only extra thing is I had to get my slope before I started. All right, so let's go to your foldable. And let's write this in. Open it up, and in there you'll see writing a point slope form when given 2 points. So we're going to find the slope by the formula. And then we're going to use steps 1 and 2 above. Okay, what this steps 1 and 2 above, if you look above, you have how to do it when you have a slope and a point. So once you find your slope, then you just put your x's in, x and y in, figure out a point and do it. And that is exactly what it tells you in the little box right above this one when given a slope and a point. Okay? All right. So let's do this one as an example in your book, in your foldable. So write a point slope equation of the line that passes through -2, -1, and 2, 4. All right, so obviously we need a point. Well, we got those, and we need a slope. Oh, need to figure out what the slope is. So here we go again. So -4 minus -1 over 2 minus -2. Wow, double negatives all over the place. Double negative, double negative. So this is really -4 plus 1, which would be -3. 2 plus 2, which is 4. So I've got my slope. So now I've got a point and a slope. So you can look in your little packet in the far right column, and it says how to do it when you have a point and a slope. So here we go. I've got a slope, all I need is a point. I'm going to pick the first point just so that we all are, excuse me, we're all on the same page. So it's going to be y minus the y of my point, which is -1, equals my slope, which is -3/4, parentheses, x minus the x of my point, which is -2. Oh, lots of double negatives there. That's going to be double negative. That's a double negative. So let's clean that up. So it'd be y plus 1 equals -3/4 x plus 2. Simple, simple. Got it in the foldable. All right. Now, what if you're given a graph and asked to write it, an equation in point slope form? Well, again, it's called point slope form because I need a point and I need a slope. Well, I can get them both from that graph. So this graph has two places with dots on it, here and here. Again, let's use, unless the directions tell you otherwise, let's use the first point. Like if we were reading this graph from left to right, like a map, like a book, let's use the first point. In this case, it would be this point right here. And what is that point? Well, that's the point -1, 2, 3, 4, 5, -1, 2. So that's -5, -2. So now I've got my point. Now all I need is a slope. Well, a slope, I'm just going to find the slope between those 2 points. So I'm going to rise 1, and I'm going to go to the left, run 1, 2, 3, 4. So that's a -1/4 slope. Because I went up and then to the left. So I got what I need. I got a point and I got a slope. So it's going to be y minus the y of my point, and that's a -2, so I'm going to put a +2, equals the slope, -1/4, x minus the x of my point. That's going to be a double negative, so I'm going to put +5. There's my equation. Pretty good. Let's do another one. Again, I'm given 2 points. And if I was reading this like a book from left to right, this would be the first point I'd come to. What is that point? Well, that point is -1, 2, -1, 2, 3, 0. So let's use that point. And now let's figure out the slope. So I'm going to figure out the slope between the 2 points. So from this one, I'm going to go up 1, 2, run 1, 2, 3, 4, 5. So I went up 2 over 5. So my slope is 2/5. Okay, so my slope is 2/5. The point I'm going to use is -3, 0. So the equation is going to be y minus the y, which in this case is 0, equals slope x minus -3, which is a double negative, so +3. Now, if you happen to use this point, this is the point 1, 2, 1, 2, this is the point 2, 2, your equation would look a little bit different. It'd still be correct. It would just look different. It would actually look like it would be y minus the 2 here. You'd still have the same slope of 2/5, and it'd be x minus the 2 here. That would be another correct answer. However, to keep it consistent within our class, let's try to remember to use the first one. So if you're reading from left to right, this one would be the first one you'd come to, right here. And that's why we use that one. Okay. All right. We're almost done. Now let's graph, given the point slope, let's graph it. Well, okay, if I'm given the point slope form, what is the point that's staring at you there? Remember, points come, ooh, that's a funky thing. Picked a weird deal. I need a point. Remember, the first one's the x, the next one's the y. So you got to go way over here to find the x. Don't jump and get that 3 from over here with the y. You have to find the number with the x. And remember, it's the opposite of that number. So the point's going to be a -1. And now jump over here to find the y, and it's going to be opposite of -3, so 3. So that's the point. And then, of course, the slope is right here. It's your m. So I'm ready to go. I just go to that point, -1, 1, 2, 3, and I'll rise over run. 1, 2, 1, 1, 2, 1, 1. I can't go off. Let's go 1, 2, 1. There's my line. If it's not in a line, I've done something wrong. So there we've got the line. It extends forever and ever. Amen. Another one. What is, here's, this is point slope form. You can tell by looking. So what is the point? Oh, gotta get rid of that. Goodness gracious.